In this video, we will look at how can we find the statistic based on the regression equation analysis output. In previous video, we already know how can we get the regression output for our multiple regression model with the categorical variables. And if you forget how the example looks like, please go back to look at the first video. So in this video, we'll look at from this general Excel output, how can we find the useful statistics to answer the analysis question. So first, the first question is very important because we need to identify where is our regression equation. As I mentioned in the simple linear regression video, analysis video, and for the Excel output, we have three parts. The first part is regression statistics, and you can find the coefficient determination from this area, also the standard error for the whole model. And the second part of the Excel output called ANOVA table. From this table, we usually find MSE, SSE, SST, and SSR, and more importantly, we will find the F statistic and the p-value for the F statistics. And the last part, the third part of Excel output called regression equation. So from the regression equation, we can first find our regression equation. The second is we can find the significance, the p-value, which we will use to do the hypothesis testing to test the significance of the partial coefficient. And also we can find the confidence interval for the partial coefficient in this area as well. So now let's starting from the top to the end to introduce the useful statistics. So in first part, regression statistics. So the multiple R in the simple linear regression model will be very useful because we are looking at the relationship between one X and Y. However, in the multiple regression model, we have multiple X. Obviously, we will not consider the multiple R in this case, but we will use the R square. So the R square is R square is what we learned in the class called the coefficient of determination. So for the interpretation for this variable is 49.50% variation in our GPA is explained by our regression model. And also in the lecture, I mentioned adjusted R square. So the reason we want to use adjusted R square is because we want to eliminate the case that people trying to keep increasing the number of X variable so that to increase the value for R square. And the standard error. So standard error is the SE when we are trying to calculate the confidence interval or prediction interval for the mean of Y and the individual Y. We will use the standard error behind our T statistics. And the number of observation. So the number of observation obviously is our sample size N. So that is what we will use, what kind of statistics we should use from our first part of the Excel output, regression statistics. Now let's look at the ANOVA table. So since we start to learn this multiple regression model, we pay more attention on the global F tests. So what does the global F test telling us? The global F test are telling us the significance of the whole model. So that's why when we write down H noun, we will write down beta 1 equal to beta 2 equal to equal to beta p equal to 0. And the H alternative is one or more betas not equal to 0. So in that global F tests, and we will use the p-value. So where can we find the p-value? The p-value is named as significance F tests. So you should let yourself know this is the p-value for F tests. So now we finished recognize the useful information from the second part of the table. Now let's look at our last part of the regression output, which is very important. It's our regression model. So based on this part of the output, we can very quick to write. First, we can write down our regression model. So the coefficients column. For the coefficients column, telling us the value for B0, and so the H is our X1, so the 0.0898 is our B1, and X2 is represent for freshman, which is the dummy variable we defined, so that is corresponding to B2, corresponding to X2 is B2. And the next one, the 1.6932 is corresponding to the sophomore X3, so this number is our B3. And the last one, 0.4441, this is corresponding to junior, and based on definition, the junior is X4, so this is corresponding to B4. So the regression equation will be equal to y hat equal to 0.6898 plus 0.0898 times x1 plus 0.9033 x2 plus 0.4441 x3 1.6932 x3 plus 0.4441 x4. So this is our regression equation. So the next question is, are those variables are significant? So in order to test whether the beta 1 to beta 4 significance differ from 0, we'll use t-test, individual t-test. So where can we find the p-value for our t-test? So that's from the column called p-value. So under this column p-value, we will use all the information except the first row, because the first row is test the significance of B0, and we don't mind if B0 is significant or not. We are more interested in to test if the B1 to B4 is significant or not. So we just need to look at the p-value from, in this case, from E18 to E21. Then we found all these values are p-value, right? And all of them are larger than our significance level 0.05. Then we will conclude none of these betas are significantly different from 0, and none of these variables significantly affect our GPA. So that is where you find the p-value for the t-tests. So the last one we want to look at is how can we find the confidence interval for partial coefficients related to our betas. So actually it's obviously in our third part of the Excel output. So the lower 95% and the upper 95% is the place for us to find the confidence interval for the partial coefficients. So yeah, why we care about confidence interval for partial coefficient, because we will use this interval to look at the significance of our betas. So for instance, if we look at the 95% confidence interval for the partial coefficient corresponding to H, and we found it's from negative 0.2690 to positive 0.4486. So from this interval, you will conclude that 0 is in this interval, then we have 95% confidence to believe the beta 1 can be 0. Therefore, if the beta 1 equal to can be 0, and the beta 1 is not significantly different from 0, give a 95% confidence level, and we will conclude the age is not significantly different from 0. Age is not significantly affect our GPA. So you will have the similar conclusion for our beta 2 to beta 4. So here is a place for us to find the useful information to get our significance of the partial coefficients. So before I end this video, at the end I want to introduce the method to get the t-statistic, which you should use to calculate the confidence interval for the mean of y and the prediction interval for the individual y. So you first type in equal sign and using t-inverse. No matter what version you are using, if you type in the t-inverse without the dot in the middle between t and inverse, you should be okay. And the parentheses. So type in 0.05. Although in the formula you can see it's alpha divided by 2, however in this function t-inverse is naturally recognized this is the two-tailed test. So when you put in the 0.05 in the first entry, what the computer will do actually is to do 0.025 to get the answer. So now the second degree freedom, as before, the degree freedom is the degree freedom of the residual. Then you can select the residual. In this case, it's B13 cell, and close the parentheses and push enter on the keyboard. You got 4.3027, and you will use this number to calculate the confidence interval for the mean of y and prediction interval for individual y.